Okay there, young students of chemistry. So, now that you have learned how to determine whether a compound is ionic or covalent, using a rule of thumb that if it starts with a metal, it is ionic, and you have learned how to model the bonding that is occurring using dot structures, and you've also been able to determine the polarity of a covalent bond. So we subtract electronegativity values, and when we have covalent bonds, sometimes the electron density shifts to a more electronegative element. Sometimes if the electronegativity values are similar, there is no electron shifting, and that would make a nonpolar bond. We need to talk about molecular polarity. So what we're talking about here are molecules, covalent compounds only. Remember that we call ionic compounds formula units. So we would say that a molecule is polar if it exhibits an overall dipole moment, meaning that the electron density is shifted in such a way that one portion of the molecule has a positive charge, while the other one, where the electrons are shifted towards, has a negative charge. And excuse me. And in the laboratory, well, not this laboratory, but more advanced laboratories, we can tell if a molecule is polar because if we put it in a magnetic field, it will align itself. I don't know if you've ever seen that demonstration where a teacher will put a magnet under a piece of paper and then shake some iron on there. As a matter of fact, if you've not seen that demonstration, you should ask me to show it to you because it's easy to see the magnetic field lines. And polar molecules, because of their polarity, will align themselves within a magnetic field. So in order to determine molecular polarity, we have to consider a couple of things. The first thing we have to consider is that are the bonds creating any polarity themselves? So when we have these electrons being shared between two atoms, are those electron densities shifting toward one atom or the other? If those are not shifting, the molecule cannot be polar. So the first thing you always want to consider is the bond polarity. If the bonds are nonpolar, if there is no electron density shift, then the molecule cannot be polar. And then the other thing that you need to consider is the geometry of the molecule. So if the bonds are polar, now you have to look at the geometry, because sometimes the geometry of the molecule will allow those dipole moments to kind of cancel each other out. You can kind of think of it as a tug of war. If the central atom is a ring that has strings tied to it, and the ligands are, the teams that are pulling on the rope that's tied to the string, if those are equal and opposite forces, they're going to cancel each other out, and there's no central atom, there's no movement on that tug of war. So there's kind of this, you would think there's no one wins that tug of war. However, if there's one team that is stronger than the other, then someone's going to win the tug of war. If we apply that to a molecule, so you have the central atom, you have these ligands that are pulling on the central atom. If at some point we don't have equal and opposite forces that are canceling each other, and the net force is in the direction towards one molecule, then that someone's going to win the tug of war, and that would be a polar molecule if someone is winning the tug of war. This is a little introduction for you once you build your molecules in your lab so that you can kind of see, once you build them, you'll be able to see if those forces are canceling each other out, the forces of the polar bonds. So you want to defer to shape, the overall shape of the molecule. And if the geometry allows those poles to cancel each other out, then the molecule is nonpolar. If they do not cancel, then the molecule is polar. So just to be clear, a molecule can only be polar or nonpolar. Bonds can be nonpolar covalent, polar covalent, or ionic. But of those covalent bonds that form molecules, The molecule itself can only be polar or nonpolar. So when we're talking about bond polarity, we use the words nonpolar covalent, polar covalent. When we're talking about molecular polarity, we use the words polar or nonpolar. And this is important because it determines a lot of properties of the compounds. It determines water solubility relative, most importantly, water solubility. But it also determines relative melting points and boiling points, stuff like that. So that is the purpose of determining molecular polarity.